Welcome to Behavioral Patterns. In this video, we are looking at the iterator pattern, one of the most fundamental patterns in software design and the foundation of the for-of loop and generators you use every day in TypeScript. By the end, you will know exactly what problem it solves, how to write one, and when to skip it. Imagine you have a playlist object backed by a linked list. To loop over it, your UI code reaches in and follows next pointers directly. Later, you swap the linked list for an array, and now the UI code breaks. The real problem is that the client had to know the internal structure just to walk over it. As collections grow more complex, trees, graphs, paginated results, this coupling becomes a serious maintenance burden. Think of a remote control for a music player. It exposes one operation, next, and that is all you need. You do not care whether the songs are stored on a disk, a hard drive, or streamed from the internet. The iterator pattern works the same way. It gives every collection a standard remote, so the caller just presses next and never touches the internals. The gang of 4 gives this pattern 4 named roles. The iterator interface defines the contract, typically hasNext and next. The concrete iterator implements that contract for a specific data structure and keeps track of the current position. The iterable interface marks a collection as something that can produce an iterator. The concrete collection implements iterable and hands back a fresh concrete iterator on demand. The client talks only to the iterator interface, so it is completely decoupled from the storage details. We start with two interfaces. Iterator declares hasNext, which returns a boolean telling us whether there is another element, and next, which returns that element and advances the position. Iterable declares create iterator, marking a collection as walkable. Number range is the concrete collection. It holds an array of numbers, and when asked, creates a number range iterator. That iterator stores a private index starting at 0. hasNext checks whether index is still inside the array bounds, and next returns the current element, then increments index. Down in the client, we ask the range for an iterator and loop with a simple while, no array indices in sight. The client has no idea there is an array inside number range, it only speaks the iterator interface. The key insight is where the position state lives. Because each iterator object carries its own index, you can create two iterators over the same collection and advance them independently, one halfway through, while another is just starting. The collection itself is stateless with respect to traversal. This decoupling means you can replace a linked list with a binary tree inside the collection, and the client loop is completely untouched. TypeScript's built-in Symbol.iterator protocol is this pattern standardized at the language level. Reach for the iterator pattern when you want to hide a data structure's internals, when you need 2 or more traversals running in parallel, or when you are wiring a custom collection into TypeScript's for-of loop via Symbol.iterator. Skip it when you are just looping over a plain array. The built-in methods are already correct. Also be cautious, if the collection can be mutated while the iterator is active, you will need invalidation logic, and at that point, a simpler design may serve you better. To recap, the iterator pattern gives any collection a standard remote control, hasNext and next, so callers never touch internal structure. Because each iterator owns its own position, multiple traversals coexist safely. Every time you write a for-of loop or a generator function in TypeScript, you are using this pattern at the language level. Reserve the explicit class-based form for custom collections where hiding structure genuinely matters.